Alright, so let's take a look at the inverse of a rational function. Here we have y equals x plus 1 over x minus 2. And as expected, what you're going to do is just interchange the x for the y. So we have x here on the left-hand side now, and we have y plus 1 and y minus 2. So the x's are now y's and the y's are now x's. The next thing we do is we just cross multiply. We do this because we don't want to have to deal with fractions. So we have x times y minus 2. Notice that the entire denominator here, when I move it up by cross multiplying, all of it multiplies my x, which is why I need to put the brackets. So x times y minus 2 equals y plus 1. Now I'm going to FOIL the x inside this bracket, and I'm going to get x times y minus 2x equals y plus 1. Let's now bring the y's to one side and the x's to the other. So xy stays on the side because there's a y. Minus y, because I'm bringing this y to the other side, equals positive 2x, because I'm bringing the 2x to this side, plus 1. Now from the left-hand side, I see that there are two y's. I'm going to factor one of the y's out from both terms. So I've got a y, and inside my bracket what's left is x minus 1 equals 2x plus 1. Now to isolate my y on the left-hand side, what I do is divide both sides by x minus 1, x minus 1. Now would be a good time to make sure that x minus 1 is not 0, basically finding the restrictions of this. And 2x plus 1 over x minus 1 is now my inverse. I've just isolated y, so I can now put a little negative 1 in the exponent to indicate that this function that I found is the inverse of my original function.